so we're going to start with notes on 6.4. And what we're really working on today are properties of rectangles. And so we're going to work on proving different properties of rectangles and compare and contrast those to the properties of parallelograms. So let me start with a description of a rectangle. And you'll notice I said description, not definition. We're going to work on a definition of a rectangle in a minute. What would you guys say a rectangle is? Kara, what do you think?
4 right angles.
Something with 4 right angles? Can we get any more specific about it? Cody?
4 right angles. Did she just say that?
Yes. She said 4 right angles. It's a very good listening skills. All right, 4 right angles. Yes, go ahead.
I think opposite sides are congruent.
Okay, so you're starting to think some more about what the properties are. Okay, so I'm going to pause you on that because we're going to make a list of that. What about it has 4 right angles? How many sides does it have?
4.
What do we call that?
Quadrilateral.
Okay, so I'm going to start us off here. A rectangle is a quadrilateral with 4 right angles. Okay, there's a description for it. So you guys are actually heading in a direction I want you to go. What I'd like you to do is work with your group. I'm going to give you about a minute, and I'd like you to list anything that you think is going to be true about a rectangle. Okay? Things that you already know are true from another class or things you think would be true. Okay? 1 minute, go.
Opposite sides are congruent and
I'm so bad.
opposite sides are parallel.
Yeah. And then, all of them equal 360? Yeah.
We're gonna think individually first. Okay, you remember you only have 1 minute.
Oh, well,
So-
wait, which one?
What did you guys think?
Opposite sides are parallel, opposite sides are congruent.
And all the angles.
No, they have to be parallel.
All the angles I have to do. Okay, so let's go ahead and generate
I
that
thought rectangles
list.
have 4 right angles.
What did you guys think?
Something small.
Anything else that you can come up with?
Or we could be
Okay, so did you
obviously
write it down?
say angles congruent.
Do you have paper? No.
So for parallel lines, it's the opposite side. Yeah.
Are you staying with us? Are you helping your group out? Okay, did you guys already talk about that? Okay, all right, let's come together and see if we can generate a list. Let's see. Let's start with this group, or let's do this. Nose goes. Your speaker. You have to look at each other, you silly gooses. You can't tell nose goes if you don't look at each other. Let's do forehead goes. For your speakers, okay.
Forehead goes.
Forehead goes. Let's start with this group. Give me one thing on your list. Who's your speaker? All right, Miss Kara, one thing.
Consecutive sides are perpendicular.
Consecutive sides are perpendicular. And Kara, what does consecutive mean?
They're like opposite. What? Like, or they're like next. I don't know how to explain that.
You want to explain it? Does anyone else in our group know how to explain it? What's consecutive?
Next to each other.
Sides next to each other. All right, good. Let's go over here. What's one thing that you know?
So parallelogram, so all opposite sides are parallel.
Opposite sides.
Sides.
Opposite sides are parallel?
Yes.
All right. How many of you guys had this one on there? Good. How many of you guys had this one on there? Okay, good. Well, yeah, duh. Right. You guys had it. Thank you for volunteering. All right, this group over here, what's one thing?
Opposite sides are congruent.
Opposite sides are congruent. How many of you had this on your list? Very good. All right, this group, one thing.
Quadrilateral.
Okay, now we've already said that. So is there something else on there?
Parallelogram.
Okay, so you're saying it's a parallelogram. Why do you think it's a parallelogram?
Because it is opposite sides congruent and opposite sides parallel.
Opposite sides congruent and opposite sides parallel. And remember, we talked about 6 different ways to prove that something is a parallelogram last class. So let's pause on this for a second. The 6 different ways. Sarah, give me one.
All the angles, or well, this.
Okay, so you want to add another one to the list? Okay, so I'm going to come back to you for that. Let's just real quickly, what are the 6 ways that we can prove that something is a parallelogram? Jake, give me one.
If both pairs opposite sides congruent.
If both pairs of opposite sides are congruent. And so in a rectangle, we've already said that opposite sides are congruent. So that works. What's another way? So that was 1. Braden.
If one pair of opposite sides is congruent and parallel.
If one pair of opposite sides are congruent and parallel. All right, Cody, what's one way?
The diagonals bisect each other.
Diagonals bisect each other. Bridget?
If both pairs of opposite angles congruent, then quadrilateral.
Both pairs of opposite angles are congruent. And we already said we've got right angles, so we definitely fit that, huh? All right, Elijah. Was that 4? Go ahead.
If all pairs of consecutive angles are supplementary, then they are parallel.
And if we have right angles, does that fit that requirement? Very good. And Kara?
I think, I don't know if someone already said this one, but if one pair of opposite sides is congruent and parallel.
I think we did get that one. But what, did we miss one? You know me, I can't count. So I think we may have missed one on there. Which one, Glenn? Maybe about the diagonals.
Diagonals bisect each other, then it's a parallel.
Did we? Yep. Okay. Did we already say that?
Just the opposite sides are parallel.
We forgot the opposite sides are parallel. Okay. Very good. Yes, Nick.
I'm just wondering, couldn't you also state that if you bisect a rectangle, it makes a 3690 triangle?
So if you bisect a rectangle, would it make 30, 60, 90 triangles? That's a really good question. I think when you say bisect, you mean split it into 2 triangles.
Yeah.
Can you guys talk for a moment? Do you think if you bisect a rectangle into 2 triangles, would it always make 30, 60, 90 triangles? Go.
No,
The side lengths can change.
because it's bisecting 90-degree angles.
5 more seconds.
Because a square is technically a
So it would never.
Okay, time's up. Let's go with this group. What do you guys think? They go, no, why?
They think it's a 45-45, but I think it's 30-60-90.
So you guys are kind of disagreeing a little bit. Why do you think it's 30, 60, 90?
Because they have to add up to 90 and the other angle's already 90, so they all have to.
Okay, all right. What do you guys think about that? What do you think, Brady?
Well, the reason I think it's a 45-45-90 because you're bisecting it, and that means it divides it in 2, making it 45 and 45, adding to 90. And the other
That's a good question. If this were 45, 45, 90, what would be true about these 2 lengths?
It would be square.
Is it necessarily going to be a situation where these 2 lengths are the same in a rectangle? No. So is it for sure going to be a 45, 45, 90? No. What did you want to add, Sierra?
Don't the diagonals only bisect angles if it's a square or opposite?
Yes, which we're actually going to learn next class. So we don't know for sure that these diagonals bisect these angles. In fact, we actually don't know for sure how they split these up. These could be 30 and 60, but they could also be 10 degrees and 80 degrees. It could be 25 degrees and 65 degrees. We don't know, so we don't want to make that assumption. Now, we would have to have a little more information to know for sure if they created special right triangles or not. They don't always. All right, was there anything that you guys want to add to this list before we move on a little bit? What did you want to add, Nick?
Corresponding angles are supplementary.
Corresponding angles are supplementary. What else are corresponding angles besides supplementary?
Congruent.
They're also congruent. And some group walking around talked a little bit about what the angles all add up to. So the sum of the angles, which group talked about that? Was that your group, Glenn? Or was that your guys' group?
No.
It's 360, maybe a couple groups. 40, 40, 40, 40, okay? We've talked about that, how a rectangle or any quadrilateral can be divided up into 2 triangles. This is a description right here of a quadrilateral. Of a rectangle. Okay, so as we work towards a definition of a rectangle, we're gonna do 2 sometimes, always, and never questions that you're gonna work on in your groups. Okay? Now what I want to make sure is I want you to justify your conclusion. Okay, so I'm going to give you two statements. You're going to decide, are they sometimes true, always true, or never true, but I want you to justify your conclusion. So you might justify it with a theorem. You might use a diagram to show a counterexample. Okay, or maybe even more than one diagram, but I don't want you to just guess. I want you to try to get some type of evidence for why you think that's true. So here's the first one. If a quad is a parallelogram, then it is a rectangle. And the second one that you're going to look at is the converse of this. If a quad is a rectangle, then it is a parallelogram. Okay? All right. I'm going to give you guys about a minute to look that over and see what you think. Work together, please. Are you guys all still writing? Am I pushing you too fast? Okay, let me give you a chance to try to scan you. Because I'm so tall. It's very.
So one would be something.
Okay, are we done writing it? I'm going to give you one more minute because some groups weren't done writing.
The first one is sometimes, I think the second
What do you guys think?
Yeah, sometimes because they're angles.
Okay, so what evidence can you provide me for that? So talk with them, see if you can come up with some evidence. Remember, you need to justify this. What do you guys think? Have you talked about it yet?
Yeah.
Yeah? Have you been able to come up with a way to justify your statement?
because not all parallelograms have 4 right angles.
Can you draw me a picture to justify that? Okay, I want you to go up there and draw that picture. Draw the diagram that you think you should draw. You can compare these guys first if you want. And so you're doing which one, Gwen? Which statement? Is that for the first one? Okay. What do you guys think? Okay, so you could draw another one. Have you guys talked about the second one yet?
Yeah.
Yeah? How are you going to justify your conclusion for number 2?
Well, you can draw a rectangle and it fits into all of these.
Okay. All right. Okay, good.
Sorry.
What do you guys think?
Fits into all of those. Well,
And then a rectangle.
Okay. What do you guys think about number 2?
Do you write it out? Parallelogram?
No.
Oh, I wasn't.
Well, sometimes I do, but I forget about the symbol.
All right, very good. What do you guys think for the second one?
The opposite sides have to be congruent for both.
Okay, so can you put that up for me? Number 2 up on the board?
Sure.
What do you guys think? Stuck on the kind of disagreeing on the Okay. Very good. All right, what do you guys think?
How to justify the first one?
Yeah.
I just drew a square.
And then
there you go.
Oh, okay, so you used one of those stairs. Good. Nice job.
100, 160.
So when your diagram goes for the first one, right? So what was your conclusion? Sometimes. Very good. And then you drew a counterexample of that. Nice job. And Braden, you're doing number 2?
Yep.
And what was your conclusion?
That for both rectangles and parallelograms, they have both pairs of opposite sides have to be congruent.
Very good. So remember, we've got those 6 different ways to prove that something is a parallelogram. And so rectangle is going to meet those 6 requirements, such as both having the opposite sides congruent. And so it is always for sure a parallelogram. So I'm going to go back to our description of a rectangle, and I'm going to modify this slightly to change it to a definition of a rectangle. And remember, definitions are things you can use in proofs, okay? And since one of the things we're working on today is proving things, this will be something that you'll probably use in proofs. So if a quad is a rectangle, I'm going to connect it with this sometimes, always, never statement, because we know this is always true. Then it is a parallelogram with 4 right angles. Our description earlier, we did not include that it was a parallelogram. Okay, but we've been able to look at it and see it does meet the requirements of a parallelogram that we used last class. Okay, so this is something that we're going to use anytime we're trying to prove things about rectangles. We can use any of the properties of a parallelogram. And you guys might remember we had a list of 5 different sets of properties that we had with parallelograms. They all apply to rectangles, but now we have an extra piece of information right here. Okay? All right, so I'm going to give you guys each a sheet with 2 proofs on them. And you're going to try to prove properties of rectangles. And again, this might be something that you would be probably looking at using on here. Now there's 2 proofs. You can choose which proof you start with based on which one you feel like you understand more, but I'm hoping that you can take a look at both. Okay? And you're allowed to work together on these. You're welcome. Can you make your pictures?
Much of that.
Right. That's fine. If you want, you can look at both and decide which one you want to start with. Yes, work together. Yes, you're allowed to work together. No talking loud. I've been an iced tea, trust me. Which one do you guys like better? Start off with.
Probably the second one.
Second one?
They were right
Yeah.
angles. Then prove that they were congruent.
Because you just have to say they all have
Could
right
you use
angles
that to prove that it's parallelogram?
Yeah.
Yep. So you would start with
Use the
that job.
definition.
Okay. Yeah.
If a quad is a rectangle,
Yes, what do you think?
it has
You still have to
4
prove
right
that.
angles, and then you can say
They're right angles and then.
an angle and
Yeah.
B are
And so you might need to use that definition to help you do that.
That's a
Okay,
parallelogram.
good. And typically we usually don't use a symbol for rectangle. There is a symbol for parallelogram that's accepted, but there's really not a symbol for rectangle.
Can you do that?
I know, I love your picture, it's beautiful, but
What if I do like that? Like that, and then go like that.
oh my gosh, is that gonna take more time than writing 4 letters? R-E-C-T. Up to you.
If we use this definition, it would be proving it that it's a parallelogram, not that we can.
You can use it for both. So you could actually in the same step say it's a parallelogram and that it has right angles.
Okay, and then we could go from there and saying that A and B are right
Since it is a
angles and then
rectangle, those two
right
sides are
angles.
congruent, and then the other two are congruent.
Good, nice thought. Yes, Dylan?
No. This one, this diagram, that
Just use the definition if a quad.
That is one way you can do it, there's more than one way to do it.
Rectangle.
You put down that it's a parallelogram, yes, because that definition you would need to use to make that job. Okay?
With 4 right angles.
How are you guys doing?
Yeah. 'Cause then you
Good?
can do,
All right. So I have a quick question for you. You have if a quad's a rectangle, then it is a parallelogram. Okay, I see where you're going. So are you using that definition? Yeah. Good. Have you guys talked together? Because it looks like you're kind of on different spots.
Right angles.
that.
Do you want to work together on this?
Or you can
Yeah? She like looks at me like, should I? I don't know.
Because that's
Okay.
90. and
Have you,
that's
or which one are you guys working on first? This
Yeah.
one? Do you have any ideas?
Go with that.
Right. You can use that definition. And really, that definition is two parts, right? Has parallelogram and right angles. If you want, you can use them both in the same step. Okay, if that's helpful. How are you guys doing?
Okay, so we
Have you, by the way, shared this with your group yet? Yeah? Okay, let's see what you did. Then diagonals bisect each other. Now, does this match what this says?
property that they're congruent, or that they bisect.
Yep, so maybe you need to look at something a little bit different. How are you guys doing? Which one did you guys start off with? Like you like the second one a little bit? Did you guys compare your second one together? No. Oh, like each other? Yeah.
Yeah, of course.
What did you call me? Miss Fulham. She's younger than me. I told you you can call me that. Oh. Yeah. So would this lead directly to the diagonals being correct? Oh, I don't know about that. I don't know if there's a property. I thought you did that has that. Is it correct? You know, do you remember the ones that we did last class? With parallelograms? We used congruent triangles a lot. That might be something you want to consider. Okay?
No,
All right,
it
what do
would
you
be
guys
hard
think?
because
And please share
would have to
with
say
each other
that
when you did the second one. How are you guys doing?
they have a reflexive because they share BC. So you have a side.
You're trying to use the sides?
Figure it out from someone
Oh, okay.
And
You're
then you would
going
have
with triangles?
A, B, and
Okay,
DC.
And then you've got some ideas on the second one? Okay, so make sure you share them with your group. Sure. So you said it's a rectangle. Okay, now this says that the diagonals bisect each other. Is that what you said here? It doesn't say they're congruent. How do you get things congruent? Think about what we did last class. We did a lot of stuff with parallelograms and we used a lot with triangles, right? Could you use triangles somehow to get things congruent? All right, see if that idea gets you going.
Can we try number 2?
Yeah, like, well, like right angles are congruent. Do you still have to say right angles?
First you have to say that they're right angles.
Do you still have to do that?
Yes, you do have to do that. Yep. In fact, there's one thing I want you to think about. Did you use this definition anywhere? You will need to because you're trying to use stuff about, see, we don't actually have a theorem that's like this. We have a theorem that says if it's a parallelogram, then the opposite sides are congruous. You might have to insert, and I don't mind if you draw an arrow and insert it in. So Cindy, you don't have to erase if you don't want to. You can just draw a little arrow. Okay. What do you guys think? Okay, if a quad is a rectangle, the only one we have for rectangles is that. It is a parallelogram with 4 right angles. This is what we're trying to prove it, so we can't use it. So you should start with
Wait a
this.
minute.
Okay, and then you might be able to go from there. Yes, not my big mistake one? Okay.
It would be segment addition, if anything. Because then you could say that bisect if a bisector equal.
I forgot what I said.
You forgot what you said? Have you guys used that in any way?
On this one?
On both of them, because
I used it on
this is
this
the only thing that we know, really. This is the only theorem that we have or definition about rectangles. So if your given is starting with rectangles, shouldn't your first theorem start if it's a rectangle? Okay, so, or your first step?
Because they both share this side. Which ones are we looking at? This one.
There is a quicker way than going through the segment addition, although that would work. You might want to think about the fact that there's triangles. I think it's 5. It's
No,
the
not the little
shortest.
ones.
6? Mm-hmm. You can use CPCTC. But you do need to...
Let me erase my coloring.
That. Mm-hmm. All right, how are we doing over here?
So this big triangle and this big triangle.
Oh, that's a good idea. That's a good idea to kind of focus in on. Good. Can I take a look at your guys' second one? Good. That's perfect. Very good. Nice job. How are you guys doing? Is this? Let's see. Do we have a theorem about if right angles? If 2 angles are right angles, then what's true about them? Then they're congruent. Okay. What are you thinking?
Okay.
Good.
Parallelogram, then
Okay, so now this is side side. You're trying to use side angle side. You should say that those right angles are congruent. Not just that they are right angles. So you go maybe insert a little step in there somewhere. All right, what do you guys think?
Oh my gosh.
We don't know?
We don't know.
You're just confused? It's okay. Let's see where you're at so far.
3.
All right.
What would you do,
so
like,
if
say
it is a
that
parallelogram, if it quads a rectangle, then it's a parallelogram with
which
what?
is a
Four right angles.
congruent.
Have you used that information, the four
Yeah,
right
but you
angles?
don't know that the
That might be
segments
helpful
are-
because remember when we're trying to prove triangles congruent, a lot of times it's really
You don't know
helpful to
that these two are
have
congruent.
right angles because that can give us an angle.
No, if you prove that it's
side or something.
So we can use if whatever. Then both pairs of opposite angles are congruent.
You could use that, although, do you guys know which triangles you're trying to prove congruent? That might be helpful.
ABC and DBC.
So you said ABC and DCB?
Yeah.
Do you guys agree with that?
Oh yeah.
Okay, and so can you see how they would both have a right angle?
Yeah.
Is there anything else that they both have? Opposite side, so there's side angle. And then what about this? Okay. All right, let's see how you guys did. Very good.
Do we have to prove
Nice
these are
job.
congruent?
Let's see. Mia, can I please have you put up the second proof?
I got
You can put
figures.
it up on this board. Okay. Let me see how you guys are doing on the first one. Have you guys talked to each other? No. Can I have you
all
do
you
that?
do.
Real quickly? Okay.
Oh yeah, that's actually how we look right there.
Yeah,
How are we doing over here?
Erase it.
Got him? Let me take a look. Now see how here you put parallelogram and four right angles? You should probably state here that they have that which ones are the right angles.
I think you just left that out.
Just left that out? Okay.
Yeah.
Now, you might want to use 3 letters here. Okay,
So,
because of the fact
yeah,
that
there could be
there's more than one angle using vertex A,
I'll
D.
just go 1, 2.
Okay.
That works.
All right, Cody, would you mind putting that up right here?
Shot.
I'm trying to find.
This is perfect. How are you doing?
1.
Okay, so let's see how this works. Did 1 and 2, and 3 and 4. It's a rectangle. It's a parallelogram. Okay, and if it's a parallelogram, the opposite sides are congruent. And then now let's see. And then okay, right there. So you said AD, and that one and those. Okay, and then you said angle BAD. Triangle BAD, this top one and that one. And you said side angle side. Can you show me your 3 steps on where you got side angle side from? So Braden, I see you're kind of faltering on this a little bit.
That's what I was thinking. I just hadn't done it.
You just hadn't formally written it out? Okay.
Yep.
All right. So let's take a look at this. So you have the side. Now right here you're saying the angles, but the triangles that you're doing are these ones. If you're doing side angle side, you're not doing angles 1 and 2. You're doing this angle. Are those angles going to be congruent? Why? It's a parallelogram with 4 right angles. So really what you would want to say here is this is a parallelogram with, let's state the right angles. So angle ABC and angle DCB are right angles. And then you do have to say that those right angles are congruent before you can use them in the proof. All right, how are you doing? You like the second one, you don't like the first one.
Yeah, I was gonna prove
Actually, Justice really is on the right track if you want to communicate that with him. I would add in, see how right here you said with 4 right angles? You can, in that step, say that we've got some right angles.
I think we should do side.
Okay, because which triangles you're trying to prove ABC? These ones? Okay, so you might want to say that these are right.
Yeah.
Wait,
like
if
that.
parallelogram,
Because
then both pairs of opposite. Then both pairs of opposite sides are congruent.
Use them in side angle side, you have to say that.
Right, guys, I got it.
And other than that, your proof is good.
Okay, AB is congruent to DC because
Wait, so what did you put for step 3?
A is congruent to
You can say they are right angles.
Say the right angles are complete, so there's your
Why is AB and DC congruent?
and you want to show that you have congruent opposite sides. Then you can set triangles.
Did that help a little bit? Okay, good.
Wait, why?
Right, it definitely happens.
A
think?
parallelogram, then
The
opposite.
first one's definitely more challenging. Okay. So, right here or here, yeah, you're gonna use parts.
SAS.
So, do you see how this definition says that it's a parallelogram with 4 right angles? You stated it was a parallelogram. Did you state that you have right angles? So you should state that you have right angles.
All in that step?
Yeah, you can do it all in that step because that theorem or that definition covers both of those things.
Oh, okay.
So you can say that maybe those 2 angles are right angles. The goal would be to try to prove that maybe this triangle and these triangle are congruent. Okay, so we can start with right angles in order to do that, and then we maybe aim for using like side, 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 or side angle, side, one of those. Okay. Now we do have 2 different proofs being put up. These are not the only ways to do them, although they're probably the most direct ways. So what I'd like you guys to do is, as they're going up, please compare your strategy with the strategy up there. See if you agree or disagree. If they have a step that you don't have, stop and ask, is that step really important? Does that step have to be there? And why or why not? And then if you did it differently, I'd love to come by and check your solution. If you did something really differently than what is being put up here. Okay? All right. Just check in. Did you guys end up talking? Yeah. Yeah? Did something a little different than each other, so we want to compare these? Okay, so you said to rectangle limits. Okay, now, one thing that you're going to want to add here, Sierra, is make sure that you fulfill everything that it says here. It says it's a parallelogram. Because the then portion says that. And it says right angles. That means this language has to say right angles. It can't say that they're congruent. It has to match that language. So you could say that angle A and angle C are right angles. Although I want you to think real quickly about which triangles you're proving congruent. You're proving D, C, B, and A, B, C. Yeah. So you might want to use angles that are in those triangles. Because remember, there's 4 right angles. So pick the ones that are going to go in your proof. All right, what did you try? Parallelogram. Okay, now again, you kind of want to use this somehow. Now, if AC bisects BD, that means that those are congruent. Does that mean that the holes are congruent? You want to go the route of congruent triangles to do that. Okay? What do you think? Let's see. Okay. You might have to use 3 letters here, Emma, just because if you say B and C, I'm not really sure which ones you're using. Okay, and then opposite sides, reflexive, congruent triangles. Again, you'll want to kind of clean that up a little bit. Make sure you, yeah. Okay, and then put your triangle symbols in there. Good. Yours is also correct. It's a little bit different than Cody's, but yours is also correct. All right, want to check?
For this, can we say rectangle 4 right angles, or should we do the definition of a rectangle?
You should use that.
Okay.
Okay? But that's part of it, right? You would say if a rectangle, then parallelogram with 4 right angles. And that way, too, you can use any of the properties of parallelograms as well. So I would probably, if I'm trying to use that, I would say that there's right angles and that it's a parallelogram, all in the same step. Okay. Okay? All right, and Cody's still writing his up. Mia, can I have you just do a quick run through of your proof for number 2?
And so that's step 1, that's the given. Then your second step would be to prove that A, B, C, and D are all right angles. And then the theorem you use for that is if a quad is a rectangle, then it's a parallelogram with 4 right angles. And then your third step would be to prove that A and B are congruent by if right angles, then they're
Very good. Do you guys have any questions for Mia on this one?
About Cody.
I mean, walking around, that's pretty much how you guys approach it. Okay, please give me a round of applause. All right, Cody, how you doing there? You have this look on your face like...
I had 2 angles in the wrong spot.
So you might have to adjust some of your letters as you go through here?
Yeah.
Okay.
Okay.
You want to talk us through it?
Yeah, so here's rectangle ABCD. And if you have a rectangle, then you have a parallelogram with 4 right angles. So you have parallelogram ABCD and angle BAD and CDA, that's it.
Because you did your letter change on us.
Yeah. CDA are right angles.
No, I'm going to just pause you there for a quick second. First of all, why did you use 3 letters to name those angles?
Because there's multiple angles that could be named by angle A and D, so
you have to be careful there. And then on your second step, you had a lot of information on there. Why can you put both of those pieces of information on the same line?
because it gives you 2 pieces of information that you can pull out with that definition. You can pull out that it's a parallelogram and that it has 4 right angles.
How many of you guys didn't use that theorem fully as you're doing this? That's really common. This definition, I keep saying theorem. How many of you didn't use that definition all the way? Like you used a piece of it, but you didn't use both parts? Walking around, that was really common. And so just keep in mind that you are given a lot of information in that definition, so you can use a lot of information from that. Okay, go ahead, Cody.
You have to use all of it because I only named 2 right angles.
Right, instead of all 4?
Yeah.
Okay, good.
And so then you can also say that if you have a parallelogram, then the opposite sides are congruent, the pairs. And so you say that AD and BC are congruent because of that statement, and AB and CD are congruent. And then you say that the right angles are congruent because all right angles are congruent.
Do you have to say that? Do you have to say that those right angles are congruent, or is it enough to just say that they're right angles?
You told us that we
Well,
could
why?
skip.
Why do you have to?
You have to because you have to have a step to say for that angle.
Remember, when you're doing side angle side, you have to have congruent statements to match each of those steps. And if you just say they're right angles, that's different than saying that they're congruent.
And
Did you get your letters backwards again?
Yeah, they've all been flipped. And so from that you can say side angle side with steps 3 for the side, 4 for the angle, and 3 again for the side to prove that triangle ABD and DCA are congruent. And then from that you can pull CPCTC for the
AC and
yeah.
BD.
Yeah. that's
Yeah?
right.
Yeah? Okay.
AC and BD are congruent by CPCTC.
And then one other thing to think about on here is, because the triangles that you did, and you could have chosen different triangles to do. You did ABD and DCA.
Yeah.
On there. Now I want to go back real quickly to right here. Let's make sure that these are actually in the triangle. So you have AD is congruent to BC, and AB is congruent to CD. And in triangle DCA and BAD, the problem is you're never using length BC.
BC. Where, oh.
Do you see how none of these have length BC ever?
Yeah.
So
you could have done reflexive.
that's
but that
what you
would
need
be
to do.
Yeah,
An
that
extra
would
step,
be
right?
An extra step,
So
yeah.
let's just insert that in there.
Yeah.
You have to do a reflexive if you're using the 2 triangles that Cody used, because you have an AD in there. That's a pretty good problem. It's a pretty challenging problem. Okay, what type of questions do you guys have on this one? So these are the 2 main properties of parallelograms that are different than the property, or of rectangles than of parallelograms. How you doing?
I'm doing great.
You're doing great. Like Mrs. Ault, why'd you have me put that one up there? Sorry, I didn't see that.
No, it's
Reflexive
fine.
missing earlier. Okay, so there's 2 extra properties on there. Now what I'd like you to do is grab your properties sheet that we started last class, properties of quadrilaterals, this one. You have 1 minute to do the second column. Remember, you're putting a check mark next to any you believe to be true. Okay, 1 minute and then we'll compare. You may begin. Find it.
Yeah. Because they're all completely links.
Is there perpendicular?
Are you already done? Do you guys want to compare within your groups?
Yeah.
Okay, go ahead and compare within your groups with each other.
The first two. And all the.
Sierra, can I have you turn on the projector for me, please?
Diagonals are congruent. They're diagonals. Okay, can you guys
All
skip
right.
the first two?
Some of you groups compared, some of you guys didn't. But let's go ahead and compare as a whole class together on this. I have on here the ones that we did from last class. Should get brighter in a second. Let me just, can you see okay? All right, so these are the ones of parallelograms we did together last class. So let's start with the rectangles. Are there going to be any changes with the sides of a rectangle compared to the sides of a parallelogram?
No.
Okay, kind of heard both. So let's hear from somebody who said no. Are there going to be any changes? Who said no? You guys are all afraid to answer. It's because I'm so tall. You're afraid of me. I'm going to pick on Wes. What do you think? Are there going to be on any changes to the sides when we're talking about rectangles?
No.
Why not?
Because it's just a parallelogram with 4 right angles.
So when we gave that definition of a rectangle, we didn't add any information about the sides. We just added information about the angles. Okay? Does that make sense? So these are still going to be the only two properties that are true with the sides. Okay, are you going to see differences with the angles? Yeah, because we have more information about the angles. Let's see. So will the ones that were true about the parallelograms still be true? Yes. Why is that so? Still a parallelogram. Okay, remember in our definition, a rectangle is a type of parallelogram. So will the upper base angles be congruent and will the lower base angles be congruent? Yes. Yeah. How do you know that? All right angles, and if they're right angles, they're congruent. And how about this last one? Yeah. When you've got right angles, all of those properties will be true because they're both congruent and supplementary to each other at the same time. So that's really nice. All right, what about, and I added something in. Last class, after class, I realized that really I wanted to phrase this a little bit differently. I believe we did not check that last class. Is that correct? And I really wanted to write this as only one diagonal bisects the other one. Okay, just like on some of the other ones where it said only one or exactly one. All right, and that's why that's unchecked there. What do you guys think? Is there anything else that we can check beyond the parallelogram properties which we know are true? Yes, Karen?
Diagonals are congruent.
Diagonals are congruent. In fact, I want to just draw a quick diagram of what the diagonals would look like for a parallelogram and for a rectangle. And this would be a good thing for you to perhaps write down. We said that the diagonals of a parallelogram bisect each other. Go Broncos here. So I'm just going to draw them as bisecting. And then we just added in a property that said the diagonals of a rectangle bisect each other. So how would the markings look different? Don't shout it out. Please talk with your group about 10 seconds. How would the markings of this look different than that?
They're all going to be the same.
All right, your 10 seconds are up. Brittany, what do you think? How are these look?
How they're alike.
Yeah. Well, how would these look different perhaps than these markings?
There wouldn't be like one section of the whole line diagonal wouldn't be marked as congruent to the other half. It would just be all congruent, the whole thing.
All 4 of them will be congruent. They're bisected and they're congruent. So if you take congruent segments and you cut them in half, you end up with 4 segments that are congruent. Okay? So this is how the diagonals will look in a rectangle. Any questions on these properties?
Would the statement prove that all 4 segments are?
If you have congruent segments and you divide them in half, they would be congruent by the division property of equality. Okay, so the results would be congruent.